Hello, everyone. It's a pleasure and honor to be able to speak with you today. Let me share my screen and we will get started. So the title of the talk is a little bit long. The shorter title is, how can we leverage community-based system dynamics to combat AI bias in high-stakes domains? And I'm going to walk through that in 4 parts. First, I'm going to set a little bit of context for machine learning and algorithmic bias. Next, I'm going to walk through a case study that's going to help us understand the root cause of racial bias in a medical algorithm. And this is going to help us understand some of the problems we need to solve in this space. Third, we're going to walk through some solution exploration, primarily focused on what it might mean to upgrade the product development process. And then finally, we're going to talk about building trust and capability, because I think that's fundamental to being able to realize some of these solutions that we're going to explore. Starting with context. Many in the tech world believe that we're in the midst of the 4th industrial revolution. The 3rd industrial revolution was characterized by technologies like the transistor, electronics, basic computing, and the beginning of the information technology age. This 4th industrial revolution is driven by technologies like genome editing, augmented reality, robotics, 3D printing, quantum computing, and the premier technology is artificial intelligence, primarily because AI is actually helping to foster innovation in all those other technological spaces that I just talked about. Now, I want to spend a little time getting us on the same page with respect to machine learning and how it's produced. So I'm going to walk through a basic machine learning development pipeline. So all these pipelines are designed to deliver one key thing, and that's a model that can perform tasks like predictions or make decisions. Now, these models have multiple names. They're also called, the algorithm. People also call them the other black box or the black box. And they call it the black box because oftentimes we don't understand how this model makes its decisions. Now, a key step for creating the model, of course, is to train it. But that takes place in a very specific context. And we're going to be talking about it within a product development context. And that context is driven by humans making critical decisions that are going to impact how that model is trained, how it performs, and deciding when you're going to roll it out. Now, the folks that are playing these roles are product managers, engineers, and analysts. Now, I mentioned that first key step is to train the model. Training the model requires lots of data. And then once you have fed the data to the model and you start to train it, you want to get to the point where you can evaluate it, test and evaluate it, and get confidence that it can perform to the level that you want it to perform. Now, typically, this is where the conversation would stop with respect to the typical machine learning development pipeline. But there's a key part of this picture that's not shown that typically gets ignored and abstracted away. We're going to be focusing on that today. And that part of the picture is, where does all this data come from? The data drives the whole process, but we often don't talk about where the data comes from. And it's coming from society. And society, as we know, is this kind of dynamically complex system. It's really hard to understand. I call it the other black box in this system because just like the model on the right-hand side, it is very hard to understand. We don't understand how it produces results. It's just as inscrutable. Now, the society is also the data generating process, right? So for the statisticians, that will sound familiar. It's the ultimate data generating process for everything that drives machine learning. But we tend to abstract this away when we develop machine learning these days, and we think we need to change that. Now, eventually you'll get to the point where you've trained your model, you've tested and evaluated, you're ready to roll it out to the world, and now you're going to take inputs into your model from the real world, from society, as opposed to from test data. And then there's going to be this feedback loop, right, that starts to generate results that get fed back into society. So you see that you have this really powerful loop that started with society, that provided all the data that trained this model, and eventually it's going to get fed back into society, which again is going to impact the data that gets generated for the next round of training models. So what can go wrong in these sorts of systems? One of the key issues is that there's a presence of bias and key points that influence how these systems get created. Of course, society itself is inherently biased, right? We have things like racism and ageism, gender discrimination. And of course, within that product development context, you have humans who are driving all the decisions, and we also bring biases with us. So it's not a surprise that these systems generate a phenomenon called algorithmic bias. And that's what we want to focus on trying to mitigate. Now, it turns out that due to historical and structural inequities that exist in society, marginalized communities are disproportionately vulnerable to AI bias. So the first major article that came out in the world that was really addressing the issue of machine learning bias came out in 2016, and it was about a risk prediction algorithm, a risk assessment algorithm to predict whether or not someone who has offended before or been convicted of a crime, whether or not they would reoffend. And it turned out that this algorithm was racially biased against African Americans. A more recent example is associated with a facial recognition algorithm, which have also been recognized to not perform very well on people from the marginalized community. In this case, somebody actually lost their liberty because the algorithm mistakenly identified them as the culprit in a crime. So the key point here is that AI bias is not something that's going to happen in the future. It's happening now. It's causing real harm now, which makes solving it an urgent issue. And so you'll see every day some headline about AI bias in the world. So this is a significant issue for society, for the businesses that are creating this technology that needs to be addressed. And you can start to see that it's impacting, how people in society think about technology production. So a couple of quotes from some studies. 65% of Americans agree that tech companies often fail to anticipate how their products and services will impact society. That's from Pew Research in 2018. Very similar sentiment from Europe. People are afraid that new technologies will cause more harm than good in coming decades to society. So people are talking about that part of that picture of the machine learning development pipeline that we often abstract away. And that's one of the reasons that we have a hard time mitigating this bias. So of course, people have started to try to address this problem. Back in 2016, new types of institutions spun up. One was the AI Now Institute, another was the Partnership on AI, and the other was a Conference on Fairness, Accountability, and Transparency. This is an academic conference where people study AI bias, its origins, and study how we can mitigate it and solve it. Now, I want to read a couple of quotes from some of the leaders from these institutions because they said some really important things a few years ago that I think has not gotten enough attention, and we're going to focus on those today. This first quote is from Christian Lum. She is a major leader in the space of machine learning fairness. And back in 2018, she said, how can we declare a model fair without understanding the broader context within which that model operates? In other words, we can't declare a model fair unless we understand that broader context. So what is this broader context she's talking about? We're going to dig into that in a few seconds. The next quote is from the AI Now Institute. And they said back in 2017, producing technologies that work within complex social realities and existing systems requires understanding social, legal, and ethical context. So again, you have this theme of needing to understand context. What are they talking about? So I think it's pretty straightforward to me that they're all saying very loudly, we must understand that other black box. We must understand it in order to mitigate bias in these systems. And so they use terms like broader context, social, legal, and ethical context. We think about those as one concept altogether. We call it societal context. And we think it's really important that we start to learn how to de-abstract that and open up that other black box so we can consider it when we're developing ML systems. And that's what we're going to be focusing on from a solutions perspective. We meaning some colleagues of mine from DeepMind and Google and some folks in the system dynamics community wrote a couple of papers to explore solutions, particularly about how can we extend that boundary when we think about machine learning to include and incorporate societal context. And then we thought about some solutions. So these next few slides are going to be exploring some of the solutions we talked about there. To move into that space, I want to walk through a case study that helps us understand the root cause of racial bias in a medical algorithm. This particular algorithm was discovered to be racially biased about 2 years ago. And the purpose of the algorithm was to identify patients with the most complex healthcare needs so that they could be given access to special programs. The hope was that this would reduce the cost in the overall healthcare system. That was the goal of the company that created the algorithm. Unfortunately, people not selected for these special programs suffer from nearly 50,000 more chronic diseases than those who were selected. So the algorithm did not perform the way it was expected to. And the people not selected for the special programs were disproportionately Black Americans. This is why it was deemed to be racially biased. So what happened? What was the cause of this? The researchers who did this work had unprecedented access to how this model was created, all the data that was used to train it, the algorithm itself, all the people that created it. And what they discovered is that the root cause of this failure was something called target variable selection that took place during problem formulation. And the target variable is your choice out of many different factors of which you want your model to predict. And it's a very important choice. Now, I want to show you where target variable selection and problem formulation takes place within the broader product development process. Now, earlier I talked about the machine learning development pipeline. That is represented by the middle gray box here. We walked through that in detail. The right-hand box is what happens after you have evaluated your model and you're ready to roll it out. Then you have to do very specific product testing, product launching. Those two gray boxes are where we spend most of our time, maybe 99% of our time, thinking about machine learning and also thinking about how we're going to mitigate AI bias. But as we know, that's not where the bias originated. That wasn't the root cause of the failure of the medical algorithm. That actually took place way upstream in the problem understanding and formulation phase of developing this product. But we don't spend much time there right now. We need to shift that. Now, the words above all of the individual tasks here represent key decisions that are being made by humans throughout this process. And so now I want to drill into the key decisions, high stakes decisions that were made very early on in the problem understanding and formulation phase of doing this kind of work. Another thing to point out is that when we do problem understanding and formulation and this target variable selection, those are usually informal and ad hoc processes. They're not very well documented. And so that's one of the things that we want to address. Now, so when you look at the sort of decisions being made in this box, they seem pretty innocuous, right? It's like, what problems should we solve and what are the relevant factors? Turns out that's really high stakes. Who are the target users and what are their needs? What are we going to use to measure success? So these are high stakes decisions. They don't seem that important. So we wanted to really dive into how do humans make decisions in the first place and see whether we can uncover some things that can help us do things better during this particular phase. And what we discovered that we as humans, we make sophisticated causal inferences during our process of decision making. And causal inferences are our way to guess why something is happening. How are things related? What caused what? And so we make these kind of inferences based on strong top-down prior knowledge in the form of intuitive theories. Now, in the work that we've done, we call these causal theories because of their relationship to causality. But these are the models that we have in our head that we create over time as we interact with complex realities. And these models are our guesses, our theories about why certain things happen. And these have a serious impact on the decisions that we make. Now, let's take a look at how these causal theories impacted the development of this algorithm that turned out to be racially biased. So as a reminder, the machine learning problem that engineers were tasked with was to select patients with the most complex healthcare needs for special programs. And again, the business goal was to reduce cost in the overall healthcare system. That's going to be important. So the causal theory that they formed through their lens was that people with more complex healthcare needs would have spent more money on healthcare in the past. So we want to find people with the most complex healthcare needs. We need to find people that have spent more money on healthcare. And this is why they chose that as a target variable. And this was problematic. To some, it may be obvious why it's problematic, but to the designers, it wasn't at the time. But the main reason it's problematic because there are many factors that are left out of this causal theory that actually decrease how much folks in the Black community spend on healthcare independent of their healthcare needs. These are things like underdiagnosis due to bias, lack of trust in the healthcare system, wealth and income disparities, and lack of access to affordable healthcare. Now, these factors represent a subset of the healthcare system structural inequities that exist in the US healthcare system. And when you take those inequities together, you see that they actually increase the amount of complex healthcare need that exists in the Black community, while simultaneously decreasing how much the Black community spends on healthcare. Now, this impact on complex healthcare needs of these structural inequities has been borne out by COVID-19. That's been uncovered, it's not in debate. Now, when we think about this idea of understanding societal context, in the research that we've done, we think the core to that are these causal theories. It's the models that we have in our head about society that really drive what society is. This is the societal context or the broader context. These causal theories that are in our head and that are often implicit versus explicit. And so we think it's very important to start to make these explicit. But one key thing is I've drawn like a more complete causal theory, but it does not include all the complexity that we have to include when we're trying to model something as complex as society or societal context, because these are dynamically complex systems in and of themselves. They're constantly changing, not only due to inherent time delays and feedback loops between the factors that we're trying to understand. And so we have to incorporate the ability to consider that if we're going to solve this particular issue of incomplete causal theories. So what are the problems? The problems are the problem understanding and formulation steps in product development today are often informal and ad hoc. Product managers and engineers, they usually don't make their causal theories explicit, right? They're usually just in their heads, and then they make some decisions that end up influencing a product. The key stakeholders who are involved in this are typically not equipped to contend and understand the dynamically complex nature of these societal contexts, right? They don't have a system thinking basis. They don't understand system dynamics. And then finally, the lived experience expertise of the communities that are most vulnerable to algorithm bias are usually excluded from this problem understanding and formulation process. So these are the problems that we want to address. And so our approach in terms of exploring solutions was we should introduce a formal and explicit problem and understanding and formulation sub-process to the traditional product development process. And that new sub-process needs to be optimized to elicit, synthesize, and make explicit the causal theories of both target and non-target stakeholders. So not just the market you're targeting, but also folks who could be impacted because you're going to be intervening on a healthcare system, even if you're not trying to sell a product to them. This new process has to be able to contend with the system dynamics of societal context. And then finally, it must center the perspectives of the communities that are the most vulnerable to the sorts of biases we want to mitigate. And it's got to do that in participatory ways and not extractive ways, meaning we don't want to get into this mode where we are just mining knowledge from communities so we can build better products. There's got to be mutual benefit. So what's an approach to this? We landed pretty quickly on community-based system dynamics being the basis for problem understanding and formulation in this new product development process. And that's because community-based system dynamics is a participatory practice inherently for including communities in this process of developing a shared understanding of really complex problems, but through the perspective of dynamic feedback. Just like system dynamics, community-based system dynamics leverages visual tools and simulation to support heterogeneous groups getting together to co-develop explicit and transparent causal theories, which we think is the key. Now, I'm not going to go through this in detail, but this is an example. These are the two main ways, the main visual notations for representing causal theories. And we think adding this kind of formalism into the product development process early on, so that product managers and engineers can get those causal theories out of their heads, make them explicit, and then to be able to get feedback on them is really critical. Now, I think what this is, when you take a step back, what this is really about is how do you bring two communities together, two worlds together, so they can see the commonalities between the problems that they're trying to solve. So for this healthcare algorithm that was found out to be racist, the goal of the company that created this was to reduce healthcare costs, right? That's the business need and problem that they started with. So you can consider that the product and tech world. In the civil society world, you've got folks who are concerned about community/societal needs and the problems and goals that exist there. And so in this problem domain, they care about improving healthcare outcomes. So it doesn't mean they don't care about reducing costs, but their main goal is how do I improve healthcare outcomes? Whereas on the product and tech side, the main goal is how do I reduce healthcare costs? Now, if we want to bring those folks together, the key is trust. Let me go back to this. The key is trust, right? To bring these communities together, right? So that they can start to see how their problems overlap, see what that Venn diagram is. And then the next step is you have to build capability for them to be able to describe that together in a shared way that can represent the complexity, right? That can tackle the fact that we need a shared causal theory that can contend with the system dynamics. So the next section, I'm going to focus on building trust and capability because I think it's foundational and fundamental to being able to realize some of these solutions that we've talked about. So I'm going to just walk you through a 2.5-year journey that I took with some colleagues that started back in November 2017, just with going to a conference to spend time with a particular community. And it ended up about 2.5 years later, publishing a paper jointly with that community about leveraging system dynamics to solve problems associated with healthcare and AI. And this is all about humans building trust and capability. So you're going to see a lot of pictures of humans and stories as I walk through this. So as I said, this started with attending the first Data for Black Lives conference in November 2017. And Data for Black Lives, this is directly from their website, is a movement of activists and organizers and mathematicians that are committed to the mission of using data science to create concrete and measurable changes in the lives of Black people. And so one of the reasons I started with this community is, as we said, marginalized groups are the most vulnerable to AI bias. And so my goal of going there was just to spend time with people, not to go there with any particular agenda, any particular product I wanted people to help us build or solve or understand, but just to understand what problems the folks in this community were trying to solve themselves. And what I discovered is that there was this need to be able to see the commonality between the problems that lots of people were tackling independently. They couldn't see the commonality, they couldn't see the system, they couldn't see how things were interdependent. So I thought it would be a good idea to actually, at the next conference, have a systems thinking workshop so we can introduce these concepts to folks at this particular conference who are trying to intervene on really complex problems. In order to do that, I had to find an expert in community-based system dynamics. And so Sarah Chung, who's a prominent member of the SD community, volunteered to help build capacity in the Data for Black Lives community. So this is the key: humans that are ready to contribute and serve without any monetary incentives, for example. So Sarah's volunteered to do that. About 3 months later, we convinced the founder of Data for Black Lives to allow us to do this workshop at her next conference. And we decided at that time, if we're going to do this workshop, we need to make sure the people that are bringing this knowledge have the same lived experiences of the people that are going to be receiving it, right? We wanted them to look and have similar experiences, right? We wanted people to be comfortable with who was delivering the knowledge to them. So we decided we needed to train some people from that community to actually teach the workshop. So we did a learning lab with 6 people from the Data for Black Lives community and 4 Googlers to teach them community-based system dynamics. And after that, we got some volunteers to actually teach that workshop. And so over the next 3 months, they learned enough about system dynamics to actually deliver the workshop at the second Data for Black Lives conference in January 2019. And so the folks that you see delivering this workshop, they didn't have any experience with CBSD just 4 months earlier. And they ended up introducing 75 people, teaching this introduction, and it had a really significant positive impact on folks. The next thing we want to do is to focus on building capacity and trust within Google itself. So our next goal and our next milestone was to have a workshop on CBSD within Google. We had about 10 Googlers who are product managers, software engineers, user experience researchers, product policy people. These are the people that drive that product development context for machine learning pipelines, for example. And we wanted to start to expose them to a different way to think about problems. And so the problem that we focused on was a problem that Google cares about, which is misinformation. But we use that basis for them to learn the basics of CBSD. And then our next major milestone is how can we kind of connect these communities together? How can we work on a problem that's kind of common between both communities and see if we can generate real concrete models, qualitative models as well as quantitative models. And so we got some attendees from that second Data for Black Lives workshop who volunteered to build a model around the problems associated with AI in healthcare. This is focusing on diagnosing skin problems specifically. And the result was that we actually were able to develop a model and ended up publishing that as a paper that was published at last year's ISDC conference. And that paper won a Lupina Honorable Mention Award. So that was kind of the end of this journey. And we spent quite a bit of time building trust and capacity, but you can't rush these sort of things. And that's really the main message. So the summary of what I covered today is that there's a requirement of a deep understanding of the societal context in which we're going to be deploying these AI systems. If we want to proactively mitigate bias, we have to have that understanding. We think a participatory problem understanding and formulation sub-process is going to be important to add to the existing product development process for getting this understanding. And we're really convinced that community-based system dynamics is going to be a promising approach for operationalizing this. But we think the key for product organizations is building trust and capability. And the only reliable foundation for building trust and capability, we think, is genuine concern for the needs, problems, and goals of the most vulnerable communities above and beyond what the business problem is. We have to start with the communities and what the problems are that they're trying to solve. So my closing kind of statement is that building this kind of trust and capability cannot be rushed. Expediency will not serve us well, and it all comes down to humans relating to each other and building trust over time and learning together, building capability together. So I'll stop there, and I'm looking forward to Q&A.
Thank you so much, Donald, for this very nice presentation. And let's open it up. We have a question here by Jim Hines, and he asks, does system dynamics have a role in helping people understand the social context? And, you know, understanding system dynamics as a white box approach and the social context, you know, for all of this black box, all of the mental models that might be captured there.
Yeah, I mean, I think the main point I wanted to get across here is we think that system dynamics has a core role in helping to make that black box into a white box, right? To make it more transparent, because the core of that black box are the mental models that people have in their head, the causal theories they have about how the world works that are often implicit but drive key decisions that they make in terms of how they develop products. And so, in particular, we think group model building, that aspect of system dynamics, is really important to make explicit, right? What are these mental models? Because those are the main drivers and forces that drive the dynamics in these systems that we're trying to intervene on with products. And also that folks are trying to intervene on with policy and with movements on the civil society side. We want folks to be able to work together with a common understanding, a common theory, a common hypothesis of what the underlying systems and structures are that they want to intervene on. And those underlying systems and structures are what make up societal context.
So thank you for that. Tom Fiddeman is asking a long question. I will try to summarize this, but so even if you don't have an AI, right, the feedback loop between society, the model, exists through mental models, people's priors about race, gender, and other. So history suggests that different social conditions can cause those models to converge to more equitable behavior or to diverge into these various type of isms. Now, AI researchers like you are clearly working towards equity, but do global incentives for less mindful AI researchers favor equity or just short-term and local performance? And if that's not the case, how do we manage these evolutionary pressures on AI development to keep it serving society, right, in the broadest and positive way?
Yeah, I mean, that's a good question. I mean, I think, I definitely believe that you have forces on either side, right? You have forces where people really care about equity, but you also have forces where people care about short-term approaches, right? This is what the world is made up of. But the key is that with AI in particular, there's like this wake-up call where the obviousness of the fact that these technologies are exacerbating inequities is like on the news and in headlines every day. And so companies have to contend with this. They actually have to solve this. And because this brings you this convergence of like business interest and the interest of equity, right? Having to solve this problem is like a business imperative now. And so I think that provides these conditions that can, it's kind of like, what we were saying earlier, like it takes a crisis, right? Like Kate was saying. So now we're in the situation where we have a crisis with AI bias that is going to force communities together to start to really understand the commonality between the problems that they're trying to solve. And I think we're at that moment, but I think what's key is that we have to have some capabilities to even contend with the complexity of the problems that we're trying to deal with. And that's why I think systems thinking and system dynamics are so important. And this is why we're trying to build capability in that space. But I think it's critical that you have to start to build trust between these communities, because the capability needs to be developed together so that people have a common language, right? So they're thinking about, we want both players to be thinking about things from a systems perspective.
So you mentioned a case study and all of this effort to bring the two communities together, but at the end of the day, it's almost seems like a one shot. So if we were thinking about scaling it up and making sure that the product development process embeds the learnings that you had in this endeavor. So first, is it already embedded in the product development process? Second, if not, how do we would change the product development process to ensure its improvement?
Yeah, so this is really interesting. I'm thinking about what Kate again said about scaling, right? And being careful about scaling, right? And this is why I really want to emphasize that the key is building trust and capability. You can't rush that. And there's all sorts of pressures to do that. So the answer to the question, like, have product development processes been updated, right, with this new approach? They have not been updated yet. We're building trust and capability within these organizations that have been operating these product development processes for years, right? With incentive structures that back up them working the way they have been, right? You have to have incentive to change them. And so you have to help people understand, like, you're gonna build better products if you have a deeper understanding of the problems of the folks that are further away from you. You're gonna roll out products that are safe in the beginning. You're gonna discover problems to solve that you would not have even understood before, which is going to lead to better products and different products for you. And so there's a time element to, like, actually building that kind of trust, and then the capability for people to be able to think that way. So this is, again, one of those cases where, yes, at a place like Google, we think about scale, right? That's the goal, but we need to have a strong foundation for that scale, and that's trust and capability.
Thank you for that. Next, there is, of course, the possibility that the same bias embedded into the original AI model could plague system dynamics efforts as well. And maybe we have access to just one community or a fragmented perspective. So do you have any suggestions about how system dynamicists, causal modelers should structure their projects and thinking to avoid such bias?
Yeah, that's a great point, and it's so true. And this is why we really emphasize community-based system dynamics and the power of kind of group model building, because what you're trying to do in those sessions, what you're really trying to do is build a safe space for people to make their biases explicit and their values explicit, and to be able to negotiate them. Because right now the bias exists, but they're implicit. They're never made explicit for people to work together, align on them, and make sure that you actually understand that these biases are playing a role in the system that you're trying to intervene on. So we have a strong feeling about the group model building approach, the community-based system dynamics approach, building safe spaces to bring communities together, not to end up with, like, here's a model where everybody agrees, but the disagreement is also valuable information, right, that you want to actually have represented in your model, right, because those are some of the things that you're going to have to contend with. I think you're muted. I think you might have muted.
Yes, I am. Thank you. So just to build on this, there was a question associated with the specifics of group model building leading to the changes, and you were mentioning safe spaces, trust, perhaps making their mental models explicit. Are there things specific that we are missing, or those are the key ones?
No, I think those are the key ones. I mean, the thing that popped in my head is you're trying to get to the point where you have people that are in product development spaces where they get exposed to this approach, and they're like, I can do better in terms of building products, and they run with it. It's very similar. Like, if we get into this mode, we're trying to sell it to people. It's not going to work very well. We're trying to expose people so that they can run with it. So I think we have the ingredients there. The key thing is exposure, and you have interested parties that are motivated that can take it and run with it in their environments and figure out how it needs to be adapted so that it kind of works in their environments. So I think that's the key. And that's another type of kind of trust building, right? Oh, I trust this different approach to thinking about problems because it's going to help me do better in my job and in my context.
Are there implications, or I would even say benefits, for incorporating system dynamics, systems thinking in and group model building in technology education, right? So could we think about AI building upon also a foundation of system dynamics, systems thinking?
Yeah, I heard two questions there. Like, so I think absolutely in terms of technical education, uh, some of the venues I've been talking to are universities, like engineering departments, about these problems and the need for incorporating system dynamics approaches, community-based system dynamics approaches. That's been received quite well, and people are quite interested in that. So I think that is key. And then the second question seemed to be about like, system dynamics and its relationship to AI development or training. Was that what the second part of the question was? It sounded like that's what it was.
Yeah, it was stated as one, but I think that I might have, but I might have put my own bias there. But yes, I'm wondering what might be the link between machine learning and system dynamics that makes it an effective pairing.
Yeah. So that's a great question, Ashley. So this is one of the things that I'm trying to do is really kind of bridge the gap between like the AI community and the SD community, because within AI, a big topic is causality. But the approach to modeling causality is structural causal modeling, like a Bayes approach, Bayesian approach. But they use acyclic approaches to modeling causality, right? And so that means it doesn't do a very good job of incorporating feedback loops. And most folks within the software engineering world and the machine learning world, they don't know anything about system dynamics. They don't know about this other way to model causality. And so I think there's this really, great opportunity to start to bridge the gap between those communities. And I think this crisis of AI bias is bringing that opportunity, because I started off by talking about, for AI bias, you need to be able to understand, the causal aspects that are generating the data. And then that kind of brings the conversation to causality. And then you can talk about the fact, you're using this approach to model causality, but you really can't model the complexity of what it is that you're trying to intervene on with the current approaches that we have. And so that's those are some of the conversations that have been fostered by talking about AI bias and how to mitigate it.
So this is a very intriguing aspect, because I think that many in our society would praise the opportunity of have system dynamics being taught in engineering programs and in combination with AI, and to certainly support AI efforts and machine learning that would effectively reduce bias. Do we see a path forward? Would you venture in thinking what might be the steps to go forward and approach this, right? So what fruitful conversations can be put into concrete actions?
Yeah, I mean, I think I keep going back to this, but I think that there's always this fundamental thing of these of communities and building trust between them. And so, like, one of the first things that I've been thinking about is like just a symposium around thinking about causality. Like, even before you start talking about specifically, hey, we want to teach SD and engineering courses. Let's have a symposium about causality with respect to AI, but bring in players from many different backgrounds who use different techniques to represent causality, to start to build some trust, right? Start to get some common language. I think that's how these things start. And then you kind of have this flywheel where people start to do concrete things that are grounded in whatever their particular context is. But first comes awareness that this system dynamic stuff even exists, and that it is really a deep, comprehensive way to represent causality.
I'm going to ask a couple of more questions before the time runs out. Okay. And one of them is very specific. So with the specific AI that was implemented, was the racial bias eliminated? Did we get results that basically were implemented afterwards? Could you tell us a little bit more?
Yeah, they actually did end up fixing that algorithm. The main issue is that they did it after the fact, after a whole lot of harm had already happened, right? So the main issue is that it wasn't mitigated proactively. But there is the opportunity to identify these things proactively during the problem understanding and formulation process, right? Where you actually, the issue was not an incomplete understanding of what was going to be intervened on. And so these after the fact mitigations are what people focus on most because it's the easier path, right? Evaluating after the fact. We need to build capability to be proactive. And that's the main kind of lesson. I actually talked to the author of this paper, and he acknowledged, yeah, we found this, but it was after the fact. We haven't written down a solution for being able to proactively mitigate this. And we think an approach is really, it should really be focused on, making that other black box transparent, leveraging community-based system dynamics, leveraging trust and capacity building to be able to describe societal contexts.
So there was a question here that basically, or a comment, can we start referring to them as closed box and open box instead of a white and black box?
Wow, that is really good.
Yeah.
That is really good. Thank you for that feedback. 100%. That's the language makes a big difference. The language makes it
right. So since we're talking about bias, we should definitely avoid it from the way that we frame it.
Absolutely.
But there is also an interesting aspect here about legislation, right? So when we think about the broad potential impact of AI, is there a place to consider legislation that would require product development to include transparency and to even think proactively about these racial biases and other types of biases that might be embedded in the products? And how would we go out to think about implementing something like that?
Yeah, I mean, I think, legislation is definitely part of the puzzle. And there's a whole cadre of people at Google that are engaging with that. I work with those folks. I work with them on these ideas. And so we're embracing these ideas. And ultimately, I think we want to get to the point where we have enough understanding ourselves to be able to kind of promote approaches like this in product development.
Donald, thank you so much for your time. What a very nice and inspirational talk. I see a lot of opportunities for system dynamics. We are running out of time, so I wanted to welcome a hand of applause from all of us to the panelists, and also formally close the plenary session. Thank you. Thank you so much.
Thanks.